Hi, I'm Kiko Kawamura. So in this second lecture video, I will discuss three important measures: mean, median, and standard deviations. Let me start by comparing mean and median. So in the 13th class of the 7 students, 5 showed up for the first exam, while 2 blew it off. Here are the grades in order: 0, 0, 68, 79, 80, 87, and 98. Calculate the class median, including all the students and ignoring the student who slept in. B. Repeat for the average. The solution is as follows. The median of the older student is 79. However, if we ignore the student who didn't show up, the median is 80. So notice that they are not so different. However, the average is a different story. The average of the older student is 58.85, while if we ignore the first 2 students, the average is, boom, 82.4. What a big difference. Notice that the mean is much more sensitive to wide outlier than the median. So next, we will explain standard deviations. So let me remind you of the definition of sample standard deviations. For a data set of size n, the sample standard deviation is computed by the following 3 steps. Square all of the deviations from the average. Take their mean divided by n-1, which is called degree of the freedom. Take the square root of the mean. Intuitively, the standard deviation gives the measure of how spread out the data is. So let me show you some example how to calculate the sample standard deviations. For the each list below, find the standard deviations. Number 1, 1, 4, 6, 7, 8, 10. Number 2, 5, 8, 10, 11, 12, 14. Number 3, 3, 12, 18, 21, 24, and 30. So let me show you how to calculate the standard deviation for number 1. So first, calculate the average, which is 6. Next, squared all of the deviations from the average, add them up, and divide it by number of the number minus 1, which is 5. It gives you 10. Lastly, take the square root of the 10, which is the standard deviations. In the same way, we can calculate the others. The standard deviation of the second data set is square root of the 10, and of the third one is the 3 times square root of the 10. So please notice that the both first and second data set have the same standard deviations. And the standard deviation of the third one is the 3 times the standard deviations of the first data set. Is it coincidence? So let's compare each dataset. The second dataset is given by adding 4 to each data value of the first dataset. Also, the third dataset is obtained by multiplying each data value of the first dataset by 3. So since the standard deviation shows how spread out the data is, these results completely make sense. Let's calculate the mean and standard deviation for the 2007 salaries of the 50 US governors. Such a lot of data set, so I will use the Excel. But before that, let me explain the interruptions of the standard deviations. The standard deviation said how far away numbers on the list are from their average. Most entry on the list will be somewhere around 1 standard deviation away from the average. Very few will be more than 2 or 3 standard deviations away. And second, roughly 68% of the values will be within 1 standard deviation of the average, and 95% will be within 2 standard deviations. So now, let me explain how to use the Excel to calculate the mean and the average of these data sets. So first, record all the data values and highlight them with your mouse. Second, type equals average for the mean. And type standard deviation STDEV for the standard deviations. And done. Thank you for the technology to calculate the average and standard deviation instantly. See you next time.